Vector sums, magnitudes, and direction. When we are given vectors in magnitude and direction form, we can find the resultant vector. And this can be used to solve some word problems or just anything involving vectors. Find directions of vectors. There are a few things that we would want to remember in this case. The first thing is understanding how to draw vectors, which that we've already talked about recently. The second thing is our parallelogram properties. That'll come in handy when we're trying to find some angle measures. The third thing is the Pythagorean Theorem. This is we've been using for years, but it'll come in handy again when we're trying to figure out some of these word problems and using that to find sides of our triangle or angles. And the last thing we're going to want to make sure we remember when solving these problems is the law of cosines and the law of sines, because this, similar to the Pythagorean theorem, will help us find angle measures and our side lengths. Okay, this first example, vector v makes a 54-degree angle with vector u. The magnitude of vector v is 13.2. The magnitude of vector u is 16.7. Find the magnitude and direction the resultant makes with a smaller vector. Okay, so what we're doing is first draw it out. So if we have vector u, our smaller vector, and that is 13.2, and vector v, oh, sorry, that's backwards. Here's my v, and here's my u, and that is 16.7. And my angle between is 54 degrees. Okay, so now the first thing I'm going to want to do is actually, in this case, use the parallelogram method, because what I want to do is find the vector when I put them together and I start at this point right here. So what I'm going to do is draw a new vector, basically just add this vector to your 13.2, add v plus u, and then again add v plus u over here. So make a parallelogram, so we know that this will be 13.2 and this will be 16.7. And now we have a parallelogram. What that means is that these two angles are the same, so that's 54, and these two angles are the same. Okay, our resultant vector is this vector right here. So that's the vector we're actually looking for. So we need that length, which is our magnitude, and this angle right here, which we're going to call theta. Alright, so those are the two things we need to find. To do that, I'm going to want to start by finding this angle right here. The angle between my u vector and my v vector, in this case. So I'm going to use my rules of parallelograms. I know that angle 1 here and angle 2 here are equal, and I know that the other two angles are equal. So if I add them all up, I should get 360 because it's a quadrilateral. So 360 equals 54 times 2, because 54 degrees is taken twice, plus 2 times whatever this angle, if we call it x. 2 times x. Alright, so 360 minus 2 times 54 is going to give me 252 equals 2 times whatever my angle x is, which is right there. Alright, and then I divide by 2, and x equals 126 degrees. Okay, so that is my angle measure of x. That is going to be important because we're going to need that to use that and the law of cosines in order to find our angle right there, or our magnitude. So the next step, we want to find our magnitude. In this case, we do not have a right triangle, so we have to use our law of cosines. So refer back to your law of cosines, which says that one of your lengths, so we'll call it y, y squared equals your other side length squared plus the last side length, 16.7 squared, minus 2 times 13.2 times 16.7 times cosine of the included angle, which we just figured out to be 126. That's our law of cosines. So if I type that into the calculator, then what I'm going to get is y squared equals 712.27276, whatever. Be as exact as you want. And then I take a square root, and y equals about 26.7, and we don't have a unit, so it's just 26.7. So that is the magnitude of my vector. Now I just need to find my theta. Well, that theta is going to be corresponding to the direction, which was the last thing I needed to find. And to do that, I'm going to use my law of sines. Law of sines is pretty simple. You could use law of cosines again, but it tends to be a little bit more difficult. So if I want to find theta, then I'm going to take sine of theta over my opposite side of that theta, which is 16.7, equals one of my angles I know, which I know the angle 126 degrees, so it's going to be sine of 126 degrees over the opposite side, which is y, which we figured out to be 26.7. Alright, so I'm going to multiply by 16.7, and I have sine of theta equals 16.7 times the sine of 126 over 26.7. So if I type that in, I'll get an estimate answer approximately equal to 0.506. So if I take the inverse sine, theta is going to equal the inverse sine of 0.506. Okay, so type that in the calculator, and your final answer is theta equals about 30.4 degrees. Final answer. For this next one, a boat has a water speed of 40 kilometers per hour and heads due south across a river that runs from west to east at 12 kilometers per hour. So we have a boat, and we're driving straight south, 40 kilometers per hour. And then the river is flowing west to east at 12 kilometers per hour. And what we want to do is we want to find the resultant vector between the two. So how fast is the boat changing direction there, and what is the magnitude? So that's what I'm looking for right there. In this case, it's a little easier because I know this is a right angle. So I can just use my Pythagorean theorem. I want to find my theta and my magnitude, which is the green vector. Alright, so the first thing, to find my magnitude, a squared plus b squared equals c squared, and that's if c is right there. Alright, so that's 40 squared plus 12 squared equals c squared, and then I take a square root of that. So if I take the square root of 40 squared plus 12 squared, what I'm going to get is the square root of 1744, which is approximately equal to 41.76. So that means that my length, my magnitude, is 41.76 kilometers per hour. Alright, now the next thing I need to find is my direction. So that's going to be my theta. So now, since I know this side is 41.76, I can use two of the sides to find my theta. If I use tangent, then I can use the ones I already know. So I know tangent of theta is going to be opposite over adjacent, which would be 12 over 40. And then theta is going to equal the inverse tangent of 12 over 40. So theta is approximately equal to, if you type that into the calculator, 16.7 degrees. So my direction is 16.7 degrees. And that's your final answer. This last one is a lot more like the first one. You are out playing soccer with friends after school one day when you and a friend kick a soccer ball at the same time. However, you kick the ball with 55 newtons of force and your friend kicks the ball with 70 newtons of force, and the angle between the two vectors is 74 degrees. So we have you're kicking the ball 55 newtons, friend's kicking the ball 70 newtons. So we need to, and this is 74 degrees. And we need to figure out the resultant vector. So this we're going to have to go back to our parallelogram method, 70 and 55, and we need to find this vector right here, our resultant vector, and this angle right here. Okay, so the first thing I want to do is find my angle measure right here. So that's going to be 360 equals 2 times 74 plus 2x, if I call that x right there. So x equals 106 degrees. Okay, so you can do the math to figure out that x equals 106 degrees. Now what we need to find is the magnitude and the direction of that resultant vector. So that's going to be our final answer. Alright, so the first thing we're going to do is the magnitude. The magnitude is going to correspond to the length, so we use our cosine. So if we call that y, then y squared equals 55 squared plus 70 squared minus 2 times 55 times 70 times cosine of my included angle, which I already found to be 106. So y squared equals 10,047.407. So y equals approximately 100.24 newtons. So that is my magnitude. Now I just need to find the direction. So the direction is going to be my angle, and that one I'm going to use my law of sines. So my law of sines is going to tell me the sine of theta over 55, because that's my opposite, is equal to the sine of my angle, which is 106, angle x, over its opposite side, which is y, which is 100.24, and then I solve for theta. So theta is going to equal the inverse sine of 55 times sine of 106 divided by 100.24, which is approximately equal to 31.8 degrees. So my direction is 31.8 degrees, and that is my resultant vector. So those are your notes over vector sums and magnitudes and directions. Go through some practice problems. These are kind of tricky, and you might need to spend a little extra time working on these. This is kind of getting us into vector-based word problems, because these are vector-based word problems. And then you can take your quiz.